Okay, good afternoon, everyone. Can you hear me, please? Yes. Can respond by unmute or just raise your hand. Am I audible? Your end?
Yes, you are.
Yes, you can hear you.
Okay, thank you. So today is another day. We're in day 14. And as I said in the previous session, which took place on 12 this July, we covered the data frame structure part 1. And today we are going to finalize the other data structure as well. The other part of our data frame structure, and actually the last data structure. As you can all recall, we started with a vector, followed with a matrix, and then arrays. All these three have something in common, which is a homogeneous data type for all elements. And then we cover the factors, which is specialized form of vector for categorical data. And then we went to list, which capture objects, can handle, can accommodate different data types. And lastly, it is our data frame structure. Each data structure has an independent rule and important one. As we saw, vectors, number one, they play the role of columns variables when it comes to data sets. But a matrix, it is a specialized class for linear algebra application by R. But arrays, it is something similar to matrix, but with a higher dimension. When you have more than 2 dimensions, then you can capture those by using array. As for factor, as I already said, it is a specialized one dimension like a vector, but it works only for categorical data. And the list, it is an object which can accommodate any other data type and structure within it. And mainly it is used for storage, particularly when we run different statistical models in the machine learnings. And most of them in even statistical tests will be stored as a list object. So the important part of list object is to know how we can extract object from list, which was covered. We saw how we can use single bracket, how we can use double square bracket, how we can use $sign. And we came to data frame, which I said this now serves as a spreadsheet for structured data. It has got rows and columns, something which we see every day when we open Excel file, or the browser window in Stata, or data view window in SPSS, or even table from SQL. So as long as you have structured data where the intersection between columns and rows will form cell, if you need that in R, that is data frame. So it is formed, it's like by combining several vectors of equal lengths. It bears several attributes of matrix in terms of dimension because it also has got rows and columns, but also it bears attributes of list because different columns can capture different data types. And that is just a quick review. What we did up to last day, we started by creating the data, and we went all the way up to comparison between data frame on the matrix, and we started to convert because, as I said, there are three major ways you can have your data frame ready in R. Number one is to build the data frame from scratch, which we did it by using data.frame and expand.grid. And number two, another way you can have a data frame in R is by converting other data structures to R. You saw the way we converted a vector to R, the way we converted the matrix to R data frame, the way we converted the arrays to data frame, the way we converted factor, which is equivalent to vector. And we were to go to last part, which is how we can convert a list to data frame. A list to data frame. And we even saw some of the functions which can be used with data frame. And when we are doing matrix, I even pointed out the similarities and differences between matrix and data frames. And here we are today, we are supposed to start with converting a list data structure to data frame. As I said earlier, list is somehow complicated unlike other data structure, because within list, you can also have other data structures. And that is where the challenge is, because if you don't observe some of the compatibility, then it will be impossible to convert that list to data frame. Just like any other data structure, here also we have two functions, which is as data.frame and as data.list. This one is generic, which means can take any object, and it will figure out automatically the nature of the object passed within it and return the output. As for data frame.list, this is specific. It requires that the object to be passed in, it must be a list. If you pass any other data type, we expect error. Now, since a list can contain other data structure within it, it is very important to understand the different behaviors of lists when it comes to different objects. Number one, if list contain only vectors with equal length, this is very easy and direct. And you can simply move from list to data frame. But if it happens that those vectors have an equal length, there is that we call recycling trap. If it happens that the other list is a multiple, the number of elements in one vector is multiple of the other. But if the vector lengths are not equal, then it will return error. And what if that list contains a matrix? What if that list contains a data frame? What if that list contains another list? And what if the list contains array? We are going to do the first 5. The other one is so complicated, and you are advised, because even an array has got several dimensions. The advice is to extract this array from list and use array transformation to data frame. So number one here, most of the time, because we know what we are doing now, this is just a repetition. I'm going to create a list of vectors of equal length. So I'll start with this, convert list to data frame. Convert list to data frame. I'll just keep explaining. Convert list to data frame. And the number one, let's just have a list object in place. We know how we can create a list. And here, I just put a syntax for creating a list. with vectors of equal length. Sometimes you have vectors or factors. The matter is the object is one dimension. The object is just one dimension. So convert a list of vectors with equal length to data frame. How can you confirm if they have equal length? You see 1, 2, 3 for name, 1, 2, 3 for age, 1, 2, 3 for gender, which is factor. So here I created my list. And you can see here there are 3, but the simple way to confirm if they have equal length, use the function called lengths. You remember, if you just use the length function, it will count the number of objects. How many objects are there? There are 3. Name, age, and gender. These are 3 objects. And our intention is to look to the number of elements within each object. All of them are vector. So for this, use the function lengths. So if you do this, you see here, name has 3 elements, age 3 elements, gender 3 elements. So when you have this scenario, to convert this to data frame, it becomes very easy. So here, I will start with frame 1. Let me remove everything here first. I will start with frame 1. What is frame 1? Will be as data frame. Then I pass list 1. I pass list 1. So this time around, if I print this, you see now instead of returning a list, it returns rows and columns, unlike this one, which was returning a list. So as long as your list contains vectors of equal length, it is as simple like that. So here I'll say by generic function, Down here I can say by specific function. The specific function. So it is the same thing, frame 2, but now it will be as data.frame.list, which means your input object is the list. So what does it mean now? If I say here class of list 1, it will tell me it is a list. But if I say class of frame 1, it will tell me it is a data frame. So if it is required to have a data frame, then you must use this. And you'll see the difference. If we use type of, as we said, data frame is also a list. So when you use type of, for list, it will return a list. No problem. But for data frame, it will also return a list. So if you want to know the difference, you must always use class when it comes to data frame, and the list to differentiate the two. Because when you use type of, all of them will be list. Why? Because data frame is the list of vector objects of equal length. So here, you will mark the difference. Among the thing which will differentiate that for data frame, if I use view frame 1, you will see your data there in a separate window, just like that. But if I do the same, view only works for 2 dimensions. So either you must have a data frame or you must have a matrix. But what if I use a list like this? You see how it appears. So you'll never see that rows and columns structure. Not compatible for list. Not compatible for list. So why are we doing this? Because you as an analyst, anytime you can have a data source in any structure. So you'll be forced to make sure you have data frame before you proceed with data analysis, because any form of data analysis or visualization requires a frame as an internal structure. So that is it. So this is case number one, which is convert vectors of equal length. Number two case, so that one is very direct, and each of us we may need to meet with such kind of data. Vector of an equal length, list two. We have two cases here. Vectors of an equal length, but which the nature of an equal length, what is that? Create a list of an equal length vector, case one. What is case one? Multiple. Sorry. Multiple. So I'll do this list. So as usual, I can say here length is of list two. You see here, name has got 4 elements, age 2 elements, gender 4 elements. The one which is shorter is a multiple of the ones which are longer. So for this case, R will do the job, but it will do recycling. So you see here we have 4, but here we have 2, and here we have 4 again. So what you can do here, if I say this frame 3 as data.frame, so I'll just go with data.frame because we know the other one also will do the same thing. Like this. So if I try to print this, you see no error, but what happens? It recycled these 25 and 30. So for first and second, it used the complete data. But when it goes to the third one, it started recycling 25, then 30. If you have fifth and sixth, it will keep doing the same. So this approach is not recommended. Not recommended. Do not leave your data into this form, because what happens here, simply Asha is using the age of Alice and Abdul is using the age of Kes, and that is not data. That is not data. So although no error, but you should be careful when it happens that after running the length, you find that some of the values, the length of some of the vectors are not the same as others, but they are multiple. Directly, R will not throw error in this case. It will do recycling. Recycling. Recycle trap. It's a recycle trap. So this is a case of an equal length. Case of an equal length vectors. Case of an equal length vectors. Number one, case one, recycle trap. Recycle trap. Number two, an equal length non-multiple. An equal length non-multiple and equal length. This case, for example, let's just take this case, for example. When I do this, if I execute this list now, when I use length is here, length is of this. You see here, name has got 3 elements, age 2, gender 4. So even though age is a multiple of this, but 3 is not a multiple of 2 or multiple of 4. So if you try to convert this, you will get error. Frame 4, that was list 3, frame 4 as data.frame. So if I capture here list 3, you see error, the function so-and-so, argument imply different number of rows. So when you see this, you know that your vectors have an equal length because the condition for data frame, the vector length must be equal. So the moment they are unequal and they are not multiple, expect this error. So it will never create that. So this one will bring error. So always try to use this function length is to check the compatibility if all of your inputs are vectors. So this is the case of converting vector, a list which contains vectors to data frame. Is there a question before I move to another case? If someone happens to have a question, you are welcome. If no, then I'll keep moving to another scenario, which is the list contains matrix. Number 3. What if your vector contains matrix? What if your vector contains matrix? Here now we have a mixed case of vector and a convert list with matrix to data frame. Convert list with matrix to data frame. Here now, if I capture this, I'll just show you. Compatible case. Compatible case. What is the compatibility of this? The previous case, we were asked that if I print this, you see, we have a vector here. We have a price here, which is a matrix object. We have a brand here. The compatible case is if you have a vector, the length of vector must be equal to number of rows of matrices. Here, I should write this. The condition, length of vectors must be equal to number of rows, number of rows of matrices. That is very, very important. What will happen? Let us do this frame 5. This one, it will do with no problem. The only thing as a data frame, the only thing what we say here, the matrices are unpacked, created by using those names. You see these names for objects, price, and the brand. What will happen here? If you do this, you find that it converts with no problem. Why? See here, the ID will still be there, but the first column of object 1 and the second column, the first column, second column of price, it will put a price 1 for object 1, price 2 for second column. The same for brand. Brand 1 for this, brand 2 for this. Why length of vector and the number of rows must be the same is because of this. You see it here. It's going to create a number of rows. So if it happens that one case is different, for any difference, Any difference? Expect error. Which kind of differences am I talking about? Let me create a list 5 here. For list 5, for example, let me say my vector will be 4, and I will leave this to 3. I will leave this to 3. This will be 5. Someone can ask, how can I understand the compatibility? For example, you say here length. If you just use lengths, you will not get something good, because the length of matrices will count all values. So the length of vector is 3, but length of matrices is 6, because total number of rows and columns, the intersection forms 6. What we need is length of vectors and the number of rows of matrices. So check for vector. So I'll extract this. So I know the length is, sorry, I should use length, not lengths. The length is 3. And also you should check the matrix object. It will be nrow list 4, then access price. You see it is 3. And then nrow, list for $ brand. You see 3. So the moment all those are equal, then you can convert your list object with no problem. But what if they differ? Like in this case here, list 5. For list 5, since list 5, this one is 4, but this one is 3. So at least one difference, expect error. So here, if I say frame 5, frame 6 now it will be frame 6. And here I pass list 5. You see that error will always be there. That is scenario number 1. The difference between length of vector and the number of rows of n of the matrices. Or another scenario, matrix differ in rows. Matrices differ in rows. What will happen? I'll keep use this list 6. I'll change this to 3. But this one, the first matrix is 2 by 3. The second matrix, I put it 3 by 2. 2 by 3 by 2. This I put it 2 by 3. So if I print this, you see that this matrix has got 3 rows, while this 2 rows, while this one 3 rows. So the moment they differ in number of rows, even this one list will throw error. Frame 6. So here should put error. Why error? Because of this length nrow. This time it is nrow of what? List 6. The number of rows of price object is 3, but number of rows of brand is 2. So the moment they differ, if you come here, also expect error. So those are cautions which you should be aware before you start converting the list which contains a matrix to data frame. That was case number Number 2 in terms of data structure, but number 3, convert list with matrix to data frame. Number 4, convert list with data frame. Now we have data frame within data frame alongside with the other data, but you want the entire object to be a data frame. So as usual, copy this. Here I've created my data frame. So this one is the data frame demographic. You can see it there. And here in list 5, I captured this as one of the objects. So when you print this list 5, sorry, it will be list, we come all the way to list 6. So this is supposed to be list 7. When I produce list 7, if I run this, it has several objects. Number 1 is ID, which is vector. Number 2 is a matrix. Number 3 is a vector, is a data frame. The same rule, the length of vector must be equal to number of rows of matrix and the number of rows of data frame. So this must be confirmed first before you proceed, otherwise expect error. So for this one, I will not move to other cases because it is familiar or just similar to the previous one. Because data frame and the matrix, they share attributes of dimension. So number of rows of demo, number of rows of price, and number of rows of data frame. So as long as these 3 are the same, then you can convert this to your data frame with ease. So frame 8 here, frame 8, it will be as data.frame list 7. List 7. And what will happen here? You see, for matrices, it will behave similar to the previous case, but here now you see, it will take the name of the object, which is demo, and it will put dot adding the column names of data frame columns. This will help you to trace that this gender originated from demo and the age also originated from demo. So as long as the compatibility is achieved, you can always convert that one. The moment there is a difference in terms of rows for a matrix and data frame, as well as length of vector, expect error as well. So that was the 4th case. Now, what about nested list? List within a list. List within list. We call that nested case. This one is very similar to the case of data frame covered here. Nested list. So here, I created 2 separate lists. This one was list 7. So this will be list 8. So number 1, I created a list called demos. This one is our list. And I come to pass this within other object as well as this. So list number 8, if you run this, you see here list within list. You have your demo ID there, but the rest are list within list. So when you see this $, it means you have demo list object, and within demo we have another list called gender. So what will happen if you convert this to data frame? Frame 9. frame 9. The issue is what is within the list. Are they compatible? You see here, 3, 3 for one dimension, but here, this matrix has also got 3 rows. So the same condition, if it is a matrix, must have the similar or same number of rows as the number of elements in matrix. Like that, you can achieve your convention with ease. Other than that, you'll be in trouble. So here, I will say as data dot frame, then I pass my list 8. My list 8. If I list this, you'll find some similar structure. So here, ID, that object, but the rest, since they come from demo object, this one, then it will use this and the names found within that list. So it is demo gender, demo age, demo price, like that. But this price also, it is demo price 1 because within price also there is a column. There is this column. So it is demo price 1, demo price 2, as simple like that. So the compatibility here, if you want to check this, for this object here, as usual, you can just say length of what? Length of list 8, length of list 8, ID. So it is 3. But what if I want to check this one dimension within list, like this case here? I want to check this gender. So what you're supposed to do is to put a length and then your list 8 $, you put demo. Remember, demo is also a list, so you put another $, then gender. So like this, you check, you have 3. What if I want to check the number of rows for this price matrix? The same thing. You will pass a number 1 list object, then another list, and then you check your price. Here now it is number of rows because that is matrix object. So when you're passing list within list, even the nested list must be compatible to all other structure in terms of number of rows. If it happens, it is a matrix or data frame. If it is a vector, must have equal number of elements. So these are 5 cases which you can convert other data structures to data frame, sorry. So we have seen the first cases. You can have your data frame by building from the scratch, and also you can convert it from other data structures. Now here, I would like to give you some similarities and differences of data frame and the list, just like the way we did with the data frame and the matrix. And here, I would like to put all 3 cases. I would like to put all 3 cases. All 3 cases. All 3 cases, what does it mean here? Let me fetch the data frame. The first one. The first one, the very first one. Yeah. This one, list 1. List 1. Here it is data frame vis-a-vis list or vis-a-vis matrix. I'll start with the matrix vis-a-vis data frame. Versus list. So here I have list 1. You see this. And We converted this to frame 1, as you can remember, is here. Now, let me convert this to matrix 1 as matrix. I'll take this. So, you see it here. Since matrix requires homogeneous data, so you must see all of them like this. Let me use another case, which may look very similar. I will say here, age 23, 51, 30. And then height 165, 156, 181. And lastly, weight, I'll say here 71, 92, 78. I have these 3 cases. And here I can create 3 objects. What are these 3 objects? I can say I will start by creating a data frame. My frame, which is data dot frame, age, height, weight. So you have your data frame there, is there. My matrix, which I can say as matrix. I take this frame. So if you print this, you see they look similar, only that here you see this indexing and my list. I'll say here as list, this one. As a list, just like that. So we said data frame bears some attributes of list and the matrix. Now you see here similarities and differences. If I say dimension functions, dimension functions, these dimension functions will be similar, similarities. Similar, I'll put this similar to matrix, different with list. What are the functions which are similar to matrix but different with list? If I use view, for example, view my data frame, you see it there, and view matrix, you see it there, very similar. But if you put view my list, it is different. So in this case, matrix and the data frame shares attributes because this is about dimension. If I say print, for example, I'll copy this, I'll just edit function. If I say print, it is a similar thing. Print, you will see the layout of output. You see it there. You see it there, almost similar. But when it comes to list, it has different layout. But if also I say row names, my data frame, and the row names, my matrix. You see? Oh, sorry. This one, matrix do not have names because it could not have that, so it will put null. But data frame always will use row numbers as row names. And this is among the difference between matrix and the data frame. But row names, for list, it will never work. Because in list, you don't have rows and columns. So there is no such a thing. The same for column names. For column names, the list will never work. Column dot names, call names, call names. Check this. Row names, row names, row names, yeah. Call names. It will work for matrix and the data frame because they have columns. But it will never work for list because list do not have the so-called columns. Now, those are enough. Similar matrix, similar with list, differ with matrix. Similar list, different with matrix. What are those features? You can start with the length. If I put a length of data frame, I'll start with names. Names. If I just put names, it is names of the objects. So since data frame has object, it will return names just like call names. But this one, it will be null because it has 2 dimensions, rows and columns. So names is for object. And the way matrix is created is not created by using object, just like the way we do with list. In list, you can pass object, you put a name. The same for matrix. You pass object, then you put name. This is style here. This one. These are objects which are going to be returned. So matrix is not built like this. It is one vector which we tend to change the dimension. So for matrix, names will never work. But for list, it will work. So in this case, when it is names, you can use the names for list, for matrix, because matrix is just a list. Another function which is the same is length. Length also count the number of objects. For matrix, it will count the number of elements. So here it is 3, but for matrix, it will be 9 because it counts every cell, does not count objects. But for list, it will be the same number of objects. And any other stuff. Type of, for example, if I use the function type of, and this is what we'll see why it is like that. For this one, it will say it is a list. Even this one, it is a list. But for matrix, it will tell you it is a double because it returns the nature of the values captured within frame, within cells, sorry. So those is just to point out the similarities which were borrowed from list and the matrix from data frame. So that is it. Unless someone has a question before I proceed to indexing. Okay, now let us go to indexing. Data frame indexing. We have seen indexing from from other objects. Now, since the data frame is both dimension-wise, it will be indexed similar to matrix. But object-wise, it can be indexed similar to list. So data frame shares with the matrix the dimension indexing, and shares with the list the list indexing. So like here, data frame carries characteristics of two data structures. It resembles matrix in terms of dimension. It resembles list in terms of accommodating an object with different data types. So in terms of dimension, you will use this comma to specify rows and columns. And here, you can pick a specific cell. You can index entire row. You can index entire columns. How about list? For list, we have seen that you can use a single bracket. When you use the single bracket for list, it will return list object. For here, since it is data frame, it will return data frame object. But if you use a double square bracket, you'll be able to index only one column, which will come as vector. And you can also use a $sign. You can also use, oh, I went so far, indexing. Yeah, here. You can also use a $sign. So the rest, once you understand, it is similar to what we did with the vectors. So you can use integer indexing, character indexing, logical indexing, all forms which we did with data frames. So here, I will use the internal data, example data, which is called empty cars. There is example data called empty cars. So if I say here empty cars, you see this is the data with the columns and rows. And I will start the exercise of indexing by 2D. Indexing by 2 dimension. So here, I will start with the integer indexing. With integer indexing. What is the integer indexing? Row index one element. Index one element. So I'll pass here empty cars. Actually, what is that? What if I need this value here? 258. This element is situated in what? In fourth row, 1, 2, 3, 4. Third column, 1, 2, 3. So if you come here and you put your, I put my square bracket, third row, fourth column, sorry, fourth row, third column. It will return just that one element, 258. But most of the time, we don't do that in data frame. Either we index the entire row or entire column. Index entire column. I'll start with entire row. But here, you can use integer or you can use names. How I can use this? You remember the same value was situated in what? In this row. Row has got that name. So I can put that name, comma. And another one is this. This one I can type. It is not easy to copy. So the same thing. So you can either use integer or you can use character. Entire row indexing. Entire row indexing, just like what we did with the vector. You leave empty for column. So like here, it will return the entire row, fourth row, this one. It returns the entire fourth row. I think I need to recall this. Yes, it returns the entire fourth row, this one. So you leave empty for columns. And what if I need several rows? This is just a repetition of what we did with the matrix. So you specify your rows, maybe first, fourth, and seventh rows. So you get them like that. And in a similar case, you can also use names, but you will not go to that case. Index entire columns. The good thing about a data frame, we're going to do this in data manipulation, very powerful case. Entire columns. Entire columns. Entire columns, you can say here, empty cars. What was this again? Disp. So this disp is the third column, 1, 2, 3. So simply, I will leave empty for rows and I will pass the position of column like that. So it will return a vector with a list from first element to last, 160, 160, 108, just like what you see here, this entire column. If I need several columns, the approach is the same. You can take the first one, the third one, and maybe the sixth one. Sorry. You must pass C function. The moment you specify more than one, C function is there. So you see everything, the first, third, and the fifth. And likewise, you can use names in a place of integers. Like the first one, the name was what? It is MPG, disp, and WT. MPG, and then disp, and then WT. So you can use either names or you can use integers as simple like that. The other one, very important one, is logical. Logical indexing. This logical indexing, it is very powerful because it enables you to impose conditions. It enables you to impose conditions. Like, I need logical indexing for rows, empty cars. After passing empty cars, I must pass condition here, and the condition will be captured by using variables. Like, if I want to be specific for MPG, number one, I should come here and pick only MPG, and then I will impose my condition. I need MPG greater than 25, for example. Let me check. Oh, sorry. Remember, this is rows. So I have to put a comma here and leave empty for columns. If you don't do that, you'll get that error. So you see this, it has been filtered and retain only MPG greater than 25. So very, very powerful. And you can impose any condition here. Or I can say, I need to pass CYL. What is the CYL actually? You see them here. We have 684. Maybe I need only 6. Then I can put equals to 6. So you see only CYL with 6 have been returned from here. So that is a logical indexing. Why? Because if you run this alone, you just experience true, false, true, false, true, false. We covered this when we were doing vectors. And like this, you can pass any condition. I can say this or what? Or this, acceptable. But as I said earlier, more advanced syntax will come later. So this or this. When you see this one 4, it means we have used the MPG criteria. When you see something like 8, we have using CYL criteria. So leave empty for column, impose condition for rows. So like this one, no one qualified. There is no rows with CYL 6 and MPG this one. Maybe I can change the direction. But if I use less, yeah, this one. Less than 25 and the CYL 6, they are here. They are here. Or let me say less than 22, for example. Less than 22, less than 20. Less than 20, you see them here. So logical indexing is also very powerful, the same idea. The same idea. Logical indexing for columns, in which scenarios we can return status of, in which scenario we can return status of columns. Here now. I will use another, this is supposed to be SO. I need to change this. This is not empty cars. It will never work because this is another data. This is another data. Let me view another data here. You see this edge group, algo group, top group, message controls. When you say str, for example, str of this one. Let me see str. You see this? This is factor, 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 but this is numeric. These two are numeric. So, is it possible to return a logical vector for columns? For columns, we don't have greater than or less than, because in columns here, we just have names. So you cannot say greater than or less than. It will still apply for rows. But you can use the idea of data type here now. For example, there is this function here, which tend to assess the entire data. The function is called sapply. If I say sapply from base, and I pass this data, and then I pass the function is numeric, for example, is numeric. It will assess if those columns like this is edge group numeric false, is alco group false, false, but this one are true. So this is the example of logical. So if this is the case, you can still use the idea of indexing. I put this and then square bracket. I leave empty for rows because now we are indexing columns. Extract only, extract numeric data type only, for example. So this one will do the job because it is logical indexing. You see, it returns only those 2 columns which are numeric. So even if you have the entire data, I can call this, for example, SO2. SO2. So you can view this as well. You see the way you have extracted your data with the same type with ease. What if I want to extract only factor? And like this, you can do for any other character. Factor data only. So you just say here is dot factor. Yeah? It will return only factors and ignore the rest. So still indexing will enable you to do that with ease. So you see here, only factor. If you try to say structure, for this one, structure SO2, you'll see that you only have numeric. But this one, you have only factors. Eh? You have only factors. And the idea of assigning object, you can even do here. Here I can say empty cars 2. Empty cars 2. So you'll find your new small data. If you view a new small data like this. So this is indexing, but by using the 2D, 2-dimension. The 2-dimension can enable you to do that. Another way of indexing, now we can use 1D indexing, which now is a list. One data frame indexing. One data frame indexing. This, I'll go back to empty cars. We have seen this from list. And now I can, for one variable, for one column, because 1D indexing is for columns only, because lists behave like columns. You cannot do this if you need rows. So for one variable only, you have two options. Either you use $, like this, it will return a vector, or you can use double square bracket, like this one. This square bracket, you can pass in an integer, or you can pass in a name. So this will do one variable only. For several variables, for one or several variables, use a single square bracket. Use this. For this one, use double this or $. Now for this one, I want you to observe the difference. Since this one will maintain the data structure, for one variable, if you use a single square bracket, the data structure here will still be a data frame. Like here, if I put a class, this one, to tell me it is a data frame with one column. But this one, class, it will convert your data to vector. That's why you can only extract one column. So that is the major difference. This one will preserve the data structure, preserve data structure, data frame structure. So if you need data frame structure to be preserved, use this one. And it is also possible to use names, MPG, like that. But this one allows you to extract multiple data. Empty cars. Remember here, we don't put a comma because we are using the idea of list. Everything you do here is for columns. So if you don't put a comma, simply you're working for column by using the idea of indexing. So like this, you get your columns. It has nothing to do with rows. And you can also use names as well. MPG drat qsec. MPG mpg drat qsec. So you see this, it is possible. Since you are dealing with the columns only, even for logical indexing, it requires logical indexing, it requires this condition either to pick data by data type. Logical indexing for columns, because this one works only for columns. So now I can remove this comma. If you put a comma, the same results, but it means you are using 2D dimension. But here I'm using list cases. As simple like that. So the idea of indexing can enable you to achieve this one as well. So this is indexing. Simply, it is a repetition of what we did with a matrix and what we did with a list, because matrix is both a data frame is both a matrix and a list, unless there is a question about indexing, but you'd like it to end there about the indexing. Is there a question about indexing? This is famous idea. So now, I would like it to go to what we call table data, or the tidyverse data frame. Nowadays is very famous. And what is going to be the difference between table and you will see table? Data frame with matrix and the list. This one is already covered, so I'll just focus now on table and the table. What is table and the table? Number one, let us learn about the tidyverse. Tidyverse is a collection of R packages designed specifically for data science. This is it. So when you say tidyverse, is a collection of 9 packages. When you activate a tidyverse, you activate these packages as well. Like here. Right now, table object, which is tidyverse data frame. Number one, what is tidyverse? I'll say here library pacman. After library pacman, I will use pload to load tidyverse. This tidyverse, once loaded, if now I say here p loaded, it will list my loaded packages. So you see the lubridate, the tidyverse, the vectors, wherever, we are not there from the beginning. Let me restart a session for you to understand this concept. Let me restart this session. Then I will re-explain the concept. So here, if I say pacman, if I run p loaded, we'll wait for a little bit. Is still restarting. You see here, only one package is activated, which is pacman. But the moment I activate tidyverse, if I rerun p loaded, you'll see the number of packages which will be activated. You see, in exception of pacman, the rest, lubridate, focus, string R, dplayer, par, read R, tidy R, table, ggplot2, pacman, and the tidyverse itself. All these were within tidyverse. So when you activate tidyverse, it's like you activate all these packages together. With tidyverse, you don't need to activate ggplot alone, tidyr alone, dplayer alone. So if you need them several, you just need to activate the tidyverse. They created an ecosystem of data. Each package has its own use. The table is the one which handles modern data frames. dplayer for data manipulation, tidyr for reshaping data, ggplot2 for visualization, readr for data import, stringr for string manipulation, lubridate for date and time manipulation, for catsy for factors, which is categorical data manipulation, and par for functional programming. Now our case, all this, if it happens that they are returning an output, they will give you output in terms of table. Now our focus will be here, table, on this one. So this table, it is a data frame. But what makes it different? Table is a data frame, but it forces R to be lazier and more explicit. We have 6 cases here to explain the difference between data frame and the table. And you can convert any data frame to table by using as a table function. But also you can build a table from scratch by using table function and a table function. We'll see the difference. So to explain this difference, I will start with the as table. Convert data frame to table, existing data frame to table. So here now, and I will use that approach to explain those differences. Convert data frame to table. I have this class here, class empty cars. It is a data frame. Now I create empty cars. This will be 2, I will overwrite. Empty cars, let me put it 3. Empty cars 3 as underscore table from table dplayer, this one. When you view them, you will never see difference. But here now, let me ask a class of what? Empty cars 3. You see here, number 1, it is still a data frame, but it is a specialized data frame called a table data frame. When you see this is table data frame or just a table or just a data frame. So when you view them, let me remove this first. When you view them, you will never see, or you will not see differences. They're exactly the same. View, this is empty cars. But if I view empty cars 3, which is the table, you will notice one thing. You see here, number 1, those row names are no longer there. Here they were there, but in empty cars 3, they are no longer there. The rest are the same. So now let me start explaining the difference between tables and the data frame. From these, tables tells you the dimension of data number, rows and columns. I will keep copying this and then I will print them. If you print this to console, if I print empty cars, and if I print empty cars 3, number 1, you see empty cars, it printed like this. Let us now see table. When you print a table, when you print a table, you see the difference. So that number 1, it will tell you the number of rows, dimension, tell you the dimension, number of rows and columns here. 32 rows, 11 columns. This was not the case for data frame. So that is number 1, the difference between table and data frame, base data frame. The second one, table explicitly lists data type of each column here. For table, You see here, each data, there is a type below this one. Is it double? All these are double, so you'll never see difference. Let me use this one to explain the differences. ESO. Let me use this ESO. Data frame. I'll use this because it has got different data types. I'll use this ESO to enjoy the different kinds of data type. So here, SO3, SO3. So this one, you see it, and this one, SO3, here. So those differences, for Tibo, if you just print, it will tell you the nature of data type. This is ordinal, this is double. Something which is not there for data frame. Data frame will never tell you that. Something which is not there for data frame. So this one tells you the dimension. You have 88 rows and 5 columns. But data frame is silent. Data frame is silent. That is number 2. That's dimension, explicit list data type. Number 3, Tibo restricted the console printout to first 10 rows. What is this? When you go to Tibo, you see this? Tibo, it restricts 10 rows only, and it tells you there are 78 more. But data frame, it prints everything which is there. And if there are too many, they will overload your console. So you need more from Tibo. It gives you the suggestion. Put N here. If you don't need only 10, for Tibo, you can say print N equals maybe to 20 if you need more, like this. 68 more rows. So most of the time, the first few rows are enough to see the whole picture about data. But also, Tibo always return a Tibo after subsetting, unlike data frame. And this is when we are talking about subsetting one row. Like here, if I subset this, if it happens that I subset this data, maybe SO4, for example, equals to, if I subset this first data, what comes after this one? Sorry, let me use comma. What comes after this one? It will convert this to the class of this. It will no longer be a data frame. Check. Oh, it's the first column, this one. The class of this, it is no longer be a data frame, but it is a factor. This one, it is a factor. But the same thing with Tibo. See it here. If I pick this 3, remember, the same flow. If I extract it from Tibo, remember now I'm extracting this from Tibo. Instead of converting this to factor, it is still Tibo. That's why you see it is a vertical column. It is not a vector. So even if you subset one column only, it preserves the data still to be Tibo. The last one, Tibo completely disable partial matching. Tibo disable partial matching. Tibo return Tibo after subsetting. Sorry. I should copy some stuff. Tibo restricting console. print only 10 rows. Yeah, the other case is table completely disable partial matching. What actually is partial matching? For data frame, for example, here we have these three and I'll remove empty cars. Let me view this as well. View SO and the SO3. These two. So you see them here. What is partial matching? Since this is data frame, if I use $sign and just write age, still R will return that one. Partial matching with $sign. If I just put this and say age, I don't put age GP, just age, R will still recognize this for data frame. But if I do that for table, this one, if I do that for table, the same thing, age GP. So if I put here age 3, since this is a table, if I put age without a complete age group, this one will throw error. It requires the full name. It requires full name. So table disable partial matching when you index with $sign. When you index with $sign, for $sign indexing, $sign indexing, but data frame, it's okay, but this one not okay. It is very important because what if you have several columns with the same prefix of age? So you'll be in trouble. That's why table is very strict. One last thing is table does not support row names. And this one you have seen it. When you go back to print, when you go back to print, you see for table, you just have numbers in terms of rows. But this one gives you this. So for case it has row names, table does not support row names. Table does not support row names. If I do this print empty cars, you see empty cars, this one has row names. They are here, row names, because the columns variable start from here. But if you print the table version, empty cars 3, they are not there. We don't have row names. So table always do not support row names. So that is major difference between table and the data frame. So what else now? I have already explained about all those stuff. Can we create or build a table from scratch? Of course you do. And it will return, it is very similar to what you do with data frame, but there is one major difference. And what is that difference, which I should say about this one? I think I have created this somewhere. So to save time, I'll just go and copy. Create, build a table from scratch. Build table from scratch. Is it possible to build a table from scratch? Yes, just the way you do with the data frame, but it has got one advantage to use table. I think capture something here. Where is that table? Is here. Climate, for example. So instead of data frame, here I use the table. I'll use climate 1. So if you print this, you have your table there. But if I just change a function to data frame, it will do the same. Data.frame, climate 2. It is the same thing. You see now the print out. This one gives you the data type and whatever, but this one does not. But the advantage of table now, advantage of table over data frame, advantage of table over data frame. Reuse variable. Reuse variables. Like here, climate 3. If I want to change this climate, I think from kilometer per hour to meter per second. For table, I can come here and write wind 2 equals to wind divided by 3.6, for example. I need to change wind from kilometer per hour to meter per second. Since I have already created wind here, I can reuse that variable and it's okay for table. Sorry. Remember here is table. Wind is capital W. This one. So it's okay. Table can recycle, can reuse that with ease. So you have wind 2, which is 3.6 divided by this. But if you do that with data frame, it will not work. Data frame cannot reuse variable. Data.frame. So this is the advantage of why you should use table. You see it here, object wind not found. Although it is here, but it cannot recycle it. Error. For data frame, you will have error. You will error. So this is the difference between table and the data frame. Another advantage of table, you can create, which is not possible for data frame, create table row-wise. How? Climate 5. There is a function called table, which is transpose table. What you do here, you start with your column names. Like here, you put city, but you start with tilde city, and then another tilde, what? Maximum temperature, max temperature, and then what else? Humidity, and then you pass wind. After this now, check this, how you pick values. Instead of picking them column-wise, you pick them row-wise. So Arusha 2967.8. You pick this, Arusha and then comma, 69, then comma, 67, 8, 67, 8. The command is, once you reach here, you have to press enter. Do not continue from the same line. So maybe I should pick Mbeya 24, 66, 10. Mbeya, then Mbeya 24, 66, 10. 24, 66, 10. Just like that. With the data frame, there is no way you can pick values row-wise. So like this, also you can create a table just like that. So you can pick your values row-wise or column-wise. For row-wise, you must start with names, preceded with tilde. So this is how you can achieve table by using 3 functions. Is there a question before I move to table and the last one? If someone
No questions, sir.
Okay, so let me finalize with table. Let me finalize with table. What is table? Time series table. This is the same or similar to table, but if you want to do a time series or panel data analysis, previously, R did not have a specialized version for data to handle those. So you're supposed to capture data in vector format. But this one is time series data frame. It is a table which is time aware. Table which is time aware. And I'll show you different cases later. So there is a package called the FPP3, which creates what we call tidyverse. It is something similar to tidyverse because it is also a collection of packages. It has got a table package just like a table back then. This table handles the issue of data frames. So here we have table package, and we have table data which contain example data. We have Fable for modeling and forecasting, Fable tools for managing models, FITS for exploratory data analysis, and GG time for temporal graphic or visualization. But also FPP3 adopts table, dplayer, tidyr, ggplot2 from logbuild. So the moment you activate FPP3, it will also load 11 packages in total. 6 come with the FPP3, and 5 were adopted from tidyverse. So this replace TS, ZOS, and XTS package to maintain data frame workflow. So here now, why table is very important? Because table, not triple, TS stand for time series table. I have to edit this before I share. Time series table. It requires index key, and if the data is panel, also it requires key variable, index variable, sorry, not index key, index variable and key variable. And you can create this by using either as a table from existing table data frame, or by using table by building this from scratch. And the time awareness we're talking about, it can be yearly. So for yearly, you'll see something like this. Quarterly, we'll see something like this. Monthly, like this. Weekly, daily, hourly data, minutes, up to even nanoseconds. Since table is time awareness data, then it will add this awareness to your data. And from there, life will be very easy. So number one, we need to work it with time series data. So data like this one, which is data for Arusha, captured over different times. So number one, let us create a table. Convert table data frame to table. And what is that? Let us have table in place. Then I'll go back to what I have created earlier. It is there already, but this is the cross-section. I need a time series Arusha. Somewhere I wrote Arusha. Yes, this one. Arusha. Arusha 1. And I'll have here Arusha 2. For Arusha 2, I would like it to remove, this. I would like it to remove this to remain with only. I have here. Year, what? Let's see. 2022, 2023, 2024, 2025. And then I'll remove this. No worry. So if I execute this, so number one, we have to make sure that we have our table like this one. This is a table. You must have a column which recognizes time, be it date or monthly or weekly or yearly. But this is the case. Can I convert this to, can I convert that one to table? Of course. So I'll put here Arusha 3. Arusha 3 as table. Sorry, number one, I should load the packages. I don't have the function. This one. Library FPP3. So once more, if I say here loaded, you will see the list of all what we're talking about, the fables, tcbo, wherever. All of them are there. So if I say now Arusha 3 as tcbo, I will pass my table here. After passing my table, and then I will say what is the index variable. The index variable from this table is date. The index variable is date. So let me print Arusha 1 and Arusha 3 for you to see the difference. Arusha 1, print Arusha 1. When you view them, they will be just the same. And print Arusha 2, Arusha 3, sorry. What do you see here? The same thing, but this is just a table, 4 rows, 4 columns. But this one is a table, 4 rows, 4 columns, but it add what? It is daily data. It is time aware, the things which I was talking about here. So the moment you see one of these, it means that the object is a table. Every table is a table. So when you see class of Arusha 1, this one is data frame is a table. But if I say Arusha 3, it is a table, is a data frame. So each time you improve, so you see this, it is data frame, it is a table, it is table df just like here, but it is also table. So this is very, very important. So we have added time awareness. You can do that by using as a table with ease like that. What if I could convert, I put Arusha 4 here. Arusha 4, and I want to convert Arusha 2. What is the index? Remember here I captured the variable called year. The index now, I want it to be here. So you see, what will be the difference between Arusha 3 and the Arusha 4? Arusha 3. For Arusha 3, since we passed the date, it was captured as daily data, 1D, date. What are those dates? They are here. Let me view Arusha 3 and view Arusha 4. See them? Here we have date, here we have just year. So since we passed the year here, when you print them, for the date, you will see 1D for date data. It means that recognizes daily records. But this one, since we passed the year, it is 1Y. It recognizes this year yearly data. So it is a time series data. From here, you can do your time series with ease. So that is about time series. If you want to build a T-table from scratch, it is very similar. Build T-table. Build T-table from scratch. Build T-table from scratch. It is the same thing. I will copy this table, this one. Arusha will be 5 now. Here, instead of table, the function now will be T-table. But once you are done with passing your variable, you will add this index equals to, you pick this variable. Now you tell R that after everything, make sure this year is index. Make sure this year is index. So T-table is time aware. So you can build also T-table from scratch. The last concept is T-table for panel data. T-table for panel data. The table by default is for cross-section data. So if you want time series or panel, you should always move to T-table. Table and the data frame by default are there for cross-section data. So here, if I want to go to panel, first you'll have a key variable, which is for ID, and we'll have index for time. So this also, I think I have already prepared it somewhere to save time because the syntax are here. The syntax are here, but I'll have to copy it somewhere to save my time. Don't have much time left. Is here panel. So it is a table. Panel. It is a table. Remember, table is not time aware. So it is here. Most of the time you will have data as a table. And that's why we need to learn how to convert it, because we're not going to build the table from scratch. You will either have data frame or you'll either have table. So currently this is a table. I want now to make this T-table. If I just pass date alone, because this date is repeating, it is here, it is also here. This repetition will give you error. It will no longer be a time series. So if I come here and say panel 2, as underscore T-table. I will pass my existing table. Then if I just pass index, I'll say use date as index. Since the date are repeating, expect error. It will say validate table. A valid table must have distinct rows identified by key and index. So now, since the date are repeating, this one, it is also here. This one, it is also here. To make this unique, you must tell that there is a subject here, a city. This is for city. This is for, this is date for Arusha. This is date for Dar es Salaam. So the combination of key and time variable will make a record unique. So for panel data, you will also pass the key. And that's why if we're using state, I will assign the XT. You will also pass the key. What is the key? The key from there is the city. So like this will be your data for panel. So if now I print this, you see, it will state the date here, the daily data, but also it will tell you you have key variable, which is the city. And how many unique cities are there? We have 2. So this will tell you the uniqueness of key variable, while this one will tell you the nature of the time captured. Is it daily or monthly or weekly? So if you could have 26 cities, you could see 26 here. The combination between time and the city will make the record unique. And as well, you can build this from scratch. To build, although this is not common, because most of the time we'll import data from scratch. To build from scratch, what is common will be to convert, because we will always import data and it will come as a table or data frame. But to build from scratch it is also possible and similar to that. And put panel 3 here. Once you are done, captured your values, you come here and say my key. The key. Sorry, it will never work until when I change this function to Tcble. Once you change it to Tcble, you see now you have key. What is your key? It is a city. And what is your index? It is date. So once you do that, by this moment, you have your Tcble object. So once you have this data frame or data structure become easy. You remember this? Arusha 1. This one was table. But what about Arusha 3? This one is Tcble. So you can even come here and say plot Arusha 3. And what do I want to plot? I want to plot maximum temperature or wind. So since it has already been taken care, Arusha 3, where is it? Arusha 3? Wind. Plot. Object wind not found. Let me check the problem. Is Arusha 3 a Tcble? Of course it is a Tcble. Oh, the function is the autoplot, not a plot. Autoplot from fits. So here, since the data is already in a time series, so you just need to pass your column variable. You can do a lot of things here, but that now will come to the time series data. If I just pass time series 1, this one will never work because the object is not Tcble. Arusha 1, error. Error, because this one is not Tcble. So you must use table version in order to proceed with any time series analysis. It is 4 o'clock exactly, and I think I'm done. All this already covered, only that I'll just update. What can I use with the data frame? It is used for storage of data set. It is an input for data manipulation. It is an object for data import techniques. It provides data for statistical modeling and the methods. It provides data for machine learning. It provides data for spatial modeling. It provides data for visualization. And wherever you need data, the object to use is data frame. But as you have seen, we have improved versions of data frames, which is a table. We have seen those 6 advantages of table over data frames, and T-table, which is a specialized table for time series and the panel analysis. Unless you have questions, this marks the end of our data structure. Do you have questions? This is your time.
I have questions, sir.
You're welcome.
Is there a direct syntax for converting data frame to T-table?
Yes, the same case. The same thing you do for table also will be taken care for T-table. For example, Arusha 1. This Arusha 1 is the table. Let me make it a data frame. Arusha it will be 5. Yes, as data dot frame. As a data frame. So let me take this Arusha 1. So it means now our Arusha 5 is data frame. Even if I do this, if I say here class Arusha 5, you'll see it is a data frame. So the same thing, you can come here, Arusha 6. You say this as T-table. You pass your data frame, which is Arusha 5, just the way we are passing table. And then after that, you say my index is what? Is date. This is my index. So you see, it's okay if you pass a data frame or if you pass a table, all the same. I hope I have answered that one. Thank you.
Yes.
Anyone else? So from now on, if you want to do time series by using R, always you should rely on T-table. You go to FPP3, and the third verse will be of much great help. So since we are done with the data structure, the upcoming session, we are going to wind up the absolute beginner part after 15 sessions. And there, we are going to talk about what we call pipe operator, a very important operator. When we are learning about data operators, we skipped some of the things. And if I take you back here, this is this data. Go for R. When we are learning about data operators, among the things we covered or we mentioned is special operators. These, tidal-based pipe operator and the base pipe operator. We need to understand this. They are very, very important in our workflow. And we are going to focus on this on the next session. So just 15 minutes to, 45 minutes to 1 hour will be enough to talk about pipe operator. But another thing will be to study about data frame, the RStudio windows. when we are starting, we just focused on console and R script. But what about these files? How about the plots? How about the packages? How about environment? How about history? We need to talk about this so someone, if want to use RStudio, can understand each and everything. So that one will mark the end of absolute beginner session. And after that one, I think you can pause for a week before now we start the beginner session, the beginner parts, where we can see from data importing to data manipulation. Most of the concepts we're going to cover is data manipulation. So absolute beginner, other than data import, the rest will be dominated with data manipulation, which is something people always run away from. But if you want to make yourself comfortable in using any software, you should be able to do a data manipulation. Other than that, thank you for your time. See you next Saturday, inshallah. Bye-bye.
Asante sana.
Karibu. Shemeji yupo kumbe?
Nipo shemeji.